And I know this is 2 in a row, so hate me all you want. But my speaker was not able to join us today. Sorry, I'm rolling over my backpack. And bad news for him, good news for you guys, because I'm working on a new workshop, and I was going to run through the presentation part of the workshop, and then now you can I'll share the labs with you, so you can do the labs on your own. So this is supposed to be a full 7-hour full day workshop, but I'll go through the cloud native stuff with you guys, talk through it, and then I'll release the labs so you guys can have access to them. You don't need an AWS account because they're on Quick Labs, so it's $1. It's like 1 credit per lab, and if you don't have the money, can't do it, let me know, hit me up. I'll get some credits to you. I'll let you run through the lab. So we'll work through that. So today we're supposed to be building trust and the journey to the cloud, but instead we're going to talk about cloud native application modernization. So how to take your on-prem applications, do some fun magic and put them up in the cloud and use some serverless. So we're going to talk about that. I have other external speakers that have already booked with us, so can't be 3 in a row. If we get 3 in a row, we're going to have trouble. Awesome. Gotcha. Great. So yeah, October, Kafka and Kubernetes. We've got somebody from Confluent coming. Confluent are the guys who work on, that's the company that kind of spun out from LinkedIn. So they're coming to talk, one of their developer advocates. I think you guys are the cash first? Or are you guys for the, you just reached out, okay. All right, so we've got another vendor coming in that's talking about caching, cloud native, microservices. And then Devin, our native Red Hat expert, is going to be talking about operators in December. So we've got a lot planned out. I think I'm already booked out till March. So that's awesome for us and much easier on me, less stressful. So if you do want to talk, just hit me up on Meetup. I'll send you the link for the form to fill out, and we'll get you scheduled onto the Meetup. As Yukaya just reminded me that I've advertised it, but maybe most people don't know. We do have a YouTube page, so all of the meetups, if you haven't been to them, I try to record most, if not all of them, because I wasn't here for our last months, and it was kind of ad hoc anyway. But we do have a YouTube channel. Again, I think it's posted on the Meetup event page. If not, just hit me up. And we've got our first ones. We've got Intro to Kubernetes. We've got a couple other ones that people have talked about. I think the Spinnaker one's on there as well. So, and with that, I'll open it to the floor for a few minutes. Anybody hiring? Anybody looking for a job? Anybody have anything they want to announce? I know Red Hat's always hiring. They're hiring? Okay. What are you hiring for?
Actually, we're hiring for my team.
There you go.
We got some we just got 30 million.
Gotcha. Feel free to post that. Awesome. All right. Yeah, feel free to post that to the Meetup board. If you want to send it to me, I can tweet it out too. Gotcha. Yeah, still working on it. As long as you got a working product, right? And a couple clients. Okay. Okay.
So we're really like CIA users just
That's exciting. Yeah.
We're like a Aqua,
okay. Gotcha. Okay. That helps put in perspective what you told us, because I use AquaSec all the time.
Yeah, GE transportation replaced Aqua.
Gotcha. It took a little bit, yeah. It took a little bit more to work through.
Point of view, one of our customers at DHS bought Twistlock and asked us to deploy it on their OpenShift, and we actually had to rewrite their entire installer to make it run OpenShift.
So to put a little bit of perspective, maybe.
Not Kubernetes.
Twistlock, Aquasec, and your company, they'll do security scanning of containers, looking for vulnerabilities, things like that. So you can do it pre-build, or you can do it after the build, throughout your entire pipeline. So
and they also monitor the running pods.
Yeah. Runtime, yeah.
And we whitelist it, so we learn what process should be there, and we'll kill it if someone introduces a new process.
Yeah. So like if a vulnerability like Heartbleed comes out and you've got something built into your containers, when they're being scanned, those kinds of products will pick that up. And then you can, I think some of them, I think Aquasec does enforcement where you can stop them from deploying it.
Yeah. The way the non-Kubernetes do it is they created their own network proxy. You have to shove everything through it. It kind of breaks. So what people tend to do with them is only vulnerabilities.
Yeah.
And then they don't do any other features because it's too much.
I had a client trying to do the enforcement piece.
It breaks your app because the kube doesn't know about it. Your quarantine is not, and it doesn't know it's being quarantined.
Yeah.
So the only way that really works is to get something.
Gotcha. All right, thank you for that. Post me the information and I'll send it out.
Yeah, my engineer is really good when it comes to some stuff.
Okay. That's what you guys will do?
Yeah.
Awesome. Gotcha. I look forward to it. Thanks. I saw another hand in the back. So you're hiring or you're looking for a job? Looking?
Yeah.
Okay.
My contract, I'm an automation engineer.
In 2 weeks. Automation engineer. So CI/CD, all that fun stuff.
I got some CI/CD projects personally. I haven't dealt with it professionally, so I'm definitely be junior in that area.
Okay.
But eager,
What kind of automation?
what's that?
What kind of automation?
I've been dealing with Rundeck and writing in Python and PowerShell, and I'm currently working on a home automation with Python and OpenCV that will have a Raspberry Pi with a camera on it that uses motion detecting to follow people's movements, that will turn a Pennywise head in a fake sewer next to my house, follow them up and take a video of it, and then I will upload it to a website of my own design, writing the API myself, and use.
So you're insourcing all of it.
Pipeline with Jenkins, and then people can log into the website and watch the latest fun, scary videos.
All right, you're definitely gonna have to do a talk on that when you get that done. Absolutely. Yeah.
That would be a great fit at either the software engineering meetup or the open source society meetup. They would love to hear that.
Absolutely. I mean, yeah. Wherever you're giving that talk, I'm going because I want to see these videos.
I'm down. Once I finish the project, I just started it like a week ago, and I managed to break the crap out of my web server today just by trying to upload, or yesterday, by trying to upload my CA security system.
Well, hopefully.
But props on OpenCV, because I just finished an image classification project with OpenCV.
Nice.
It watches for my son's school bus every morning, so
That's
that I
cool.
know when the school bus is getting close. Because his bus goes this way and then it comes back to pick him up. And so it specifically only classifies his bus going that direction and speaks an alert, says, Colin's bus just passed.
Nice.
And I'm like, all right, buddy, heading for the driveway.
Nice. That's pretty cool. Dennis, what do you got?
Radio Sound is hiring an embedded software engineer. It sounds like you played a lot with the kind of stuff that we play around with at work. So,
Radio Sound. Yeah.
Radio
Let's
Sound.
the conversation.
Yeah, radiosound.com. Here's my card.
Boom. Community. Hashtag community. All right. Thanks. Awesome. Anything else before I jump in?
If anybody's interested in working for Red Hat, talk to that guy, because there are hiring firms.
There you go. That's Pat back there from Tech Systems. He's the guy who's so gracious enough to, set up this room for us, get us pizza and beer. So
60% of our hiring comes through Tech Systems. The other 40% comes from referrals. So
exactly. So if you do need a job, definitely talk to Pat. He's a good sounding board too. Yeah. Awesome. All right. Thanks. So again, like I was saying, apologize guys that our speaker had to cancel. So like I said, we'll run through this. You guys get to learn some new stuff about Cloud Native application modernization. Sorry, we've been shortening out where in chat, so it's been app mod. So I didn't want to say app mod out loud, and I just did. So with that, we'll go ahead and get started.
You just call it AMM at work. Modernization and modularization.
I like that one too. So again, some of this is going to be geared towards the workshop. I'll skip over the parts that are the workshop oriented, and I'll send you guys the lab. So if you are interested in doing them, you can walk through them. So like I said, we'll do introduction overview. We'll talk through some of the incremental techniques of going from on-prem to cloud native. We'll walk through some of the serverless development lifecycle, how that changes when you move to maybe more of a serverless mindset. We'll go over some of the architecture, and then I'll walk through and I'll talk to you a little bit about the labs, and we'll talk about that. Obviously, we're not going to have a lunch break unless you want more pizza will be in the back. And then we'll talk through some more of the labs and some of the services. So it's nice to intersperse between labs and services. So I'll talk, a quick blurb about the labs, but I'll go into the services. So if you have any questions, if any of this is new to you, or if you don't know, what I'm talking about, if I use an acronym, please let me know. I talk about this stuff all day. Sometimes I assume knowledge. That's my privilege, and I try to make sure that everybody knows what we're talking about, especially when we're at meetups. So this is for everybody to learn something new. That's my boss. Ignore him. That's me. Some people we're going to be working with. I'm co-presenting this with AWS in a couple weeks, so you guys are my guinea pigs to run through this. So some of the things we're going to talk about today, right, are incremental application deployment practices. So fun bit, accelerating business practices, getting through that software development lifecycle faster, cheaper, but also safer and more secure. We'll talk about the development lifecycle, design and architecture, and then what it looks like from an operating model perspective, because one of the big things around serverless is that there's no operations anymore. But that's not true. You've just shifted them to the left. So we'll talk about how it differs for the developers versus the sysadmins now. We'll talk about foundations of serverless, understand again what the cost benefit is of building a serverless application compared to a regular one. I thought you had your hand up. You're like,
oh, sorry. No.
You're like low key raising your hand. Okay. We'll go through some example serverless architectures, and then we'll walk through some of the labs. This slide is, DevOps is still relatively new to a lot of companies, so I think it's interesting when we talk about this from a financial dev perspective. A lot of the clients that I work with are, in the financial sector, and we, try to shift this into their mindset of what a traditional DevOps, containerization, microservices, all of that would look like, and how you'd shift it to, a serverless idea. So when we say it enables business teams, we say that because you're focusing on just the central core product, and you don't have the worry anymore of, is my server ordered, is it set up, all of the other things, is it patched, is it secure, all of those things kind of go away. Like I said, on number 2, all you write is your business logic. It's going to start to make sense as we go more throughout this presentation, what that means. And instead of managing servers, managing binaries, managing all the normal sysadmin stuff, now you're just managing SLAs. And how to be able to take all of these things and then be able to take a core business requirement and say, hey, customer X is asking for this, and being able to quickly turn that around for them in a 2 to 3 month cycle versus 6 months to a year, 2 years. So it's incredibly fast paced. Even 2 to 3 months, I would say, would be slow in this realm. I would say 2 weeks, a sprint, maybe 2. So. Go ahead. This is going to be more of a cloud native serverless talk versus Kubernetes. With the way that I've structured it is that it's cloud native, so It can be Kubernetes. It can be serverless, because that's still considered a CNCF project. So gotcha. Okay. Yeah. Not this talk, because this is one that would no, it's fine. We're doing this with a partnership with AWS, so this will be heavily AWS focused. There are other services. GCP just came out with Cloud Functions. Azure, I think it's just Azure Functions. So there's still serverless things, and there are serverless. So as I can remember them in my own head, I'll try to reference what they are for the other different clouds. So we can have that kind of discussion. Because in my mind, at this point in the game, in the race between the big three and DigitalOcean, it's services at this point. Everybody can run a VM. Running a VM is not hard. Scaling a VM, all this stuff. It's the services that I think are going to make people differentiators for the competitors. I don't know. As soon as I said it, Devin's like.
I was going to ask, did you mention Knative?
The point that I just made is that this is heavily focused on the AWS tool set. It would be actually an interesting one to see like what it look, his on-prem serverless, like using OpenFOSS, Knative. I'm just throwing them out there.
It's not on-prem, it's just Kubernetes.
Yeah, versus the other ones. Yeah, because wherever you can run Kubernetes. Yeah. But this is mostly just around the serverless offerings that AWS has.
To the point of the slide, my mind wants to know this, but we built it all.
Okay. Now, the interesting thing too is when I say serverless, I'm not talking about just Lambda functions. We're going to talk about all the other functions that you're just managing and tweaking and tuning instead of tuning an operating system, worrying about what your kernel params are. So. Obviously, it's not much of a sales pitch, but this is kind of the idea that Gartner has about where serverless is going, the increase in research and development that people are going to be using to deploy it. This is Gartner, so take it as you will. Obviously, it's going to be a big focus. I think a lot of people are shifting more away from operating systems, but we'll see. It takes a lot to move things off prem. A lot of banks still have mainframes, so we'll see.
Regulatory compliance makes it difficult.
Absolutely.
Heavily regulated industry, it's difficult to do something.
Mm-hmm. Absolutely agree. But I think it's part of our jobs is to show them that it is possible, but you've got to have the right controls.
This is somebody who's really more technically actually predicted that it's going to come. Basically, it'll be a transition from cloud back to the server. Depending on maybe companies that measure the cost savings that they could have had going to the cloud, and they just measure their maybe like that.
So that's one of the things that when I first do a cloud assessment with teams, they'll do the sticker shock. They'll be like, well, I have 100 servers on-prem. I need 100 servers. That's that whole lift and shift model. That's one of the things that we're going to talk about is one of the migration patterns is that, well, I've got 100 servers over here that are this big, and I'm going to need those in the cloud. And they look at it and they're like, this costs way more. And they're not thinking in a cloud native fashion. They're not thinking about auto scaling, turning things off. They don't need their dev running 24/7. They only need it running 8 to 5 when their devs are actually working, things like that. So that's part of the discussions that we have because we know every client brings that up. Well, the cloud's more expensive. It's like, well, you're not using it I think all three of them have their own framework, but it's like the well-architected framework from AWS. So they're not thinking about it from that perspective, the cost savings. And then there's also the non-financials, right? Hey, a sysadmin, having to manage that server all the time versus someone else managing it. That's some of the stuff that we'll talk about when I get into the operational constructs. So I've got a slide on that, but it's
still a big deal.
Yeah, it's interesting. This slide right here is just to demonstrate how you can get into very granular into what your application's costing you. So depending on your architecture and how you've got things set up, you can know per request how often that's being executed, how much it's costing you. So it's things like that. So when you start breaking up, you can start seeing hotspots in your application. So you can start to focus on that. You can either optimize it, you can add new functionality to it. So that's the part where you can see, and you also see what that costs you. So if you've got a set of microservices running that have all of their different Lambda functions running in serverless, you can see which ones are costing you the most or the least, and you can start to make business decisions. Is it worth us continuing to manage this, or should we move this into another piece of functionality? So you get a lot more granular, especially if you start running it through some of the architecture patterns that we're going to talk about. Because again, even though it's still Lambda and serverless, you still have to think about your architecture patterns.
Yeah, and that's kind of on the other side of that cost TCO argument that a lot of people don't consider is, yes, potentially serverless can be much cheaper per transaction, but now you have to manage potentially thousands of Lambdas, and how do you architect that to be reliable and able to wrap your developers' heads around it.
Yep. We got 3 architecture patterns that we talk about depending on how they set it up, or at least the 3 that I've seen. We can't have a serverless talk or a cloud talk without talking about this slide or some variant of it. On the left, as you talk about being on-prem, you're responsible for everything. And when you go all the way to functions as a service, that's the piece that I was talking about earlier, is that you're focusing only on the business logic. Everything else is taken care of for you. So, everything's running. Actually, you don't even know most of the time, because Lambda, I don't think they actually tell you what Lambda is running in. So it could be in a container, it could be in Fargate, it could be just running on a process on an EC2 instance. So I don't really know, because that's the idea, is that it's a black box. You give them your code, it executes when someone makes a request. So we're going to talk about the AWS's serverless offering. This is also one of my other favorite slides that I do, just because we're saying serverless, and you're not worrying about servers, but again, there is no cloud. It's just someone else's computer. It's a great sticker. I'm gonna have to find it so I can get some for everybody. It's a good one. I thought about not putting it in there because I'm doing this with AWS and they are a cloud company, but nobody's taken it out yet, so I'm keeping it.
It's just like I tend to try to use the word either FAAS or FBAS. And it annoys some of my coworkers. They're like, serverless, man. Everybody goes to serverless, and you're still serverless. You're just not managing.
Yep, that's the whole differentiator.
Reps yesterday, the internal customer, they build the relationships with partners.
Mm-hmm.
They call themselves ISPs. Like, sorry, that's our internal thing that we call it. Like, no, I don't know what this called an ISP.
Gotcha. That's funny.
So that's what AWS.
I'll have to ask, because I've been working with my partner rep on this. That's funny. I'll keep that in the back of my mind. I want to talk a little bit, just a quick, if you guys haven't seen this before, the Cloud Native Computing Foundation, they have a definition of what they consider something to be cloud native. I'm not going to read all of this. I'm just going to talk to some of the highlighted words that we've got there. So build and run scalable applications, being able to run 1 million, executions of your application all at once with, with millisecond latency. It's very hard to do. So that's one of the nice things that, serverless gives you. It's a dynamic environment. Again, dynamic. Your code's just sitting there waiting to be executed. Talk about microservices. I think most of us are pretty familiar with microservices and containers. Yes, no, maybe so. It's okay to say no. Just give me a little, okay, no, all right. Loosely coupled, that's one of the big ones that we talk about here, especially when you go into a serverless discussion, is that dependencies start to become, if you have tightly coupled dependencies, that's going to be one of the things where you might have to look to re-architecting your app to be able to run at a cloud native or a serverless realm. Resilient, manageable, and observable. Again, I know this is a AWS specific talk, but they have multiple availability zones. You can manage these all through SDKs. You can manage it through the console. There's all Terraform. There's tons of tools where you can manage all of these. And observable, everything's in there. It's all monitored, logged, and available for everyone to see. The last one I think is a big one that we tend to forget, and I think the other synonym that we use here is tech debt. So minimal toil. Toil is that sitting there waiting for something to be done. You put in a ticket, you're waiting for somebody to approve it. All of these things. I think because if you set up things and structure them properly, you can move away from that, because the way that I, in my mind, set it up is guardrails. The way that all of the structures that you have in place in AWS allow you to set up guardrails for developers that they can only do so much. You can limit their blast radius if something goes wrong, or if they try to consume too much. So you want to minimize that toil and just give them those guardrails to develop and innovate, because that's what they're there for. Anybody Rocky Horror fans? It's just a jump to the left. I got tired of the old adage of saying that we're shipping things left, and since we're talking about completely removing operations and it's in the developer's hands now, it's a jump to the left. Time warp? Nobody? Okay. I see some.
I was stuck on the first line. It's something with a friend.
Did I misspell something? On-prem. There you go.
Yeah.
Yeah. You know what? I've had like 3 people review this. Thank you.
Nobody caught that one, huh?
Nobody caught that one. Right?
Hosting.
I'll yell at them. Thanks. We'll give a quick run through, because I think 12-factor applications work really well in a serverless environment. So just going to give a quick overview of what a 12-factor is for people who may not know. There's a website out there. It's really great, 12factor.net. What it does for a lot of on-prem applications that are really used to just doing what they can to get things done, or just maybe some bad practices, allows them to take this format, this 12-factor, and taking those on-prem applications and being able to transform them into things that might be a little bit more cloud native friendly. So it says, using declarative formats to set up automation and minimize time and cost for new developers joining the project. The nice thing about that is that if you've got your structures set up in place for your applications, and if you're a Java shop, you're not doing much differentiation between project to project. It's the core business logic. So there should be no real setup time as a new developer to get used to that. Clean contracts between the underlying operating systems. The point that's talking about that it brings up is the containers is the biggest one. So being able to pick up your application's runtime and ship it and run it anywhere. That's one of the big ones. That's the easiest analogy that I can give people. Suitable for deployment on modern cloud platforms. That's one of those things, again, where it's just being able to take your application and drop it into a cloud ecosystem and it just be able to run. So all of those customizations are built into the application, so it's not as specific to your on-prem environment or a specific cloud environment. Minimizing deviance between development and production environments. The nice thing about that one in a cloud environment is that if you're running things, infrastructure as code, you can stamp out environments very easily, very quickly, and you can scale those out as the need happens. So if you're doing load testing, you can scale your load test environment up to a production level and see how it handles, throw it 2, 3, 10x amount of traffic. In a cloud environment, you're able to do that. So, and then continuous deployment. Continuous deployment's a big deal, because if you're shifting to a 12-factor or cloud native and you're iterating much faster, you're churning out a lot more code. You have to do a lot more integrations, a lot more deployments. So those have to be automated from that perspective. And then I think the underlying tone in all of this that we'll be talking about is being able to scale all of these up. So serverless being able to scale millions of requests, or in a container or a server realm, being able to scale those up from a cloud perspective. So this is the high level overview. The site, and I just locked my machine. I love those hot corners. That's my password. ... 12factor.net.
Combination on my luggage.
Right. No, it's what is it? Hunter 2.
Oh man.
Anybody? Bash.org. Oh.
Yeah.
Oh, okay. You know now.
Actually, that's the password I use for everything.
It goes through. These are the 12 factors. I'm not going to run through all of them. Actually, I don't know if I don't have slides on all of them, but you can see stuff like 5, like build, release, run, having that CI/CD process, setting up that code base or shared code base. Believe it or not, I've had clients that email code back and forth still in 2019.
Oh.
Yeah.
Like his
Yep.
patches?
No, attachments,
Zip files.
zip files. Yep.
On the network,
It-
David.
And it actually makes it through? So not
It's
the cool
internal,
way.
so yeah, it hurts. So having to have a shared code base, I mean, I think it's pretty much goes without saying that the industry is standardized on Git. Port bindings and concurrency, so that's some of the things that, just concurrency, being able to manage multiple thousands of those iterations of your application. And this disposability, being able to, since you're having that fast iteration cycle, maybe things don't make it to production because
Cattle,
you're
not
just,
pets.
yes, cattle not pets. You're trying new things because you have this speed of innovation now, because you've freed people up to do these things. And then of course the dev prod parity, being able to copy, replicate data, replicate instances, services, things like that is very, in a 12-factor cloud native world, it's very easy to do because, again, it's just code. So there's the site for it if you want to go read more. It's got maybe, I would say it's a good week's worth of reading to just kind of digest and understand everything that's on that page. But it's a good framework to help with an application modernization effort. So this is when we're going to start getting into more of the AWS focused and shift into doing a modernization. They have, as part of they have a cloud adoption framework. So as part of that cloud adoption framework, you have to look at how your applications are architected, and then you have to make design decisions on how you're going to migrate them. So you've got their 6 R's, and the way that they talk through them, I'm trying to remember. Nope. Okay. So I'll talk through these just in these slides here. So when we're talking about rehosting, so that's the lift and shift model. I've got it running on a Linux server. I've got everything I need on this server. I just pick up that app and I just run it. I configure the server like I would natively on-prem, and now I'm just doing it in the cloud. So that's that one. That's a quick win generally, but it's also, that's that whole sunk cost fallacy, that whole cost of ownership discussion that we have. So if they have 100 servers that they need to configure like that, and you do a lift and shift, they'll get that sticker shock at the end of the month when they see what it costs. So if you do AWS or you do any cloud like that, it is going to be more expensive. So
Taking your clients to these 6 phases, like
yeah. So when we're looking at their application portfolio and we say, this is a good candidate for rehosting because maybe it's got a lot of proprietary stuff or maybe, some things they don't have anymore. They don't have the people, so they just have to rehost it in AWS, which is completely valid. These are design decisions when we're looking at the application portfolio. So these are the discussions you have to have. So when we talk about replatforming, right, that's going the more cloud native route. So maybe you're running, MySQL on-prem, you can port over to running it on RDS, or you can run it on Aurora because of those are MySQL compliant. So that's kind of the replatforming, because you can, very easily switch that over, and you don't have to do any application configuration because it's still MySQL compliant.
Isn't there a cost savings though if you modernize the application and you model it?
That's
Containerized and UKI?
that's what number 4 is.
Potentially.
Yeah, that's what number 4 is. Actually, that was a good segue for me to skip over number 3 because in my mind I'm trying to remember what repurchasing is. So we'll go ahead and skip over number 3. That's a good note for me to remember. Yeah. Refactoring and re-architecting. That's the piece that you're talking about. So that's taking your application and maybe it is a batch job that runs at night and only runs does payroll processing. There's no reason that you have to have a server running that. You can run that in AWS batch and just have it run. So that way you don't need to focus. Again, this is where we start talking about the serverless. This is a good candidate for serverless. This is a good candidate for running on another service that AWS offers. So if you're hosting a giant data lake and it's petabytes of data, would it be a good idea to re-architect it and rehost it on Redshift? Because that's their data lake platform. So these are the decisions you have to make when you start looking at, you've got some quick wins, like running all your static assets out on S3. That's pretty easy because then it's just a reference on your web servers. So again, these are all discussions that you have to have. And then of course, if you're migrating to the cloud, it's a good time to have the discussion. Do we still need this application? If not, retire it. So it's a good time to reassess what your application portfolio looks like and if it's still providing the value that your business thought it was or needed. And then, of course, you can't move everything to the cloud. So the cloud providers, AWS, recognize that. So just retain. This is an application that we can't move to the cloud right now for whatever business reason, regulatory reason. Some things have to stay in-house. That's just the way it is.
So something else to be said about refactoring, re-architecting. A lot of times it's super fallaciously expensive to rewrite or refactor a large monolithic application. But if you were to move it, instead of just replatforming it onto, say, ECS, you could replatform onto EKS. And then you're only using up the tenths or hundreds of CPU units that it's actually using at a given time. And you're not actually reserving an entire EC2 instance or whatever.
It's actually a really good segue into the next thing that we're going to talk about, where we start talking about the incremental modernization. So you have decided to re-architect and rehost an application onto AWS, or you started your cloud migration. What are some of the things that you need to do to prep for it, or to help broker between moving on-prem, because not everything's on-prem, to moving something on-prem, and some of the decisions that you have to make? Yeah. That's, yeah. Yes, that's
Hence
it.
the argument going away from hosted on-prem exchange to exchange as a service or VMware.
Yeah, O365, yeah. Those, yeah. I think in Salesforce, I think, was the biggest one. Yeah. Yep.
ERP is a
Oh, yeah. Don't use oracles. Thank you for that. Some of the architectural patterns that we'll talk about, that I've got a couple of examples that I've worked with, so Devin might as well, or anyone if you've had some of these patterns. These work really well and on-prem as well. Work really well as well. Words. Well, there we go. Exactly. So circuit breaking. Circuit breaking is obviously taken from like the electrical ideas of, you've got requests flowing through, things are going on in the system, and something happens. There's a network partition, there is a zone goes down, or an application goes down. inside the application, you can recognize that and then send different types of signals back to the user. The biggest one that when I think about it is, again, this is the idea comes, Netflix has got a tool that they used to have, I think it's statistics, but the idea is that if you ever notice, like if a service is down on Netflix, you won't know about it because they do circuit breaking. So like if the personalization features are down on Netflix, they just give you the default view. So you don't even know that your personalizations are down. So if the search functionality, there are certain things. So it's like, because these are microservices and they can be independently controlled and operated, because they know that they're down, they can respond to that.
Does it sound like a grand scale failover?
I wouldn't say a grand scale failover, but because they know about each other, they know about their downstream and upstream dependencies. If something's going wrong, they can see something happening in the system, they can decide to respond differently than they would. So like the circuit's open or it's closed or it's half open. If the service is, running too high, so if they know the latency is at X, they know that the service is really bogged down right now, so they can just wait. So it's just building that kind of architectural pattern into your applications.
Actually, the trend nowadays is to let your platform do that for you. That's what Istio and some of the other various service meshes allow you to do. And then it's platform, framework, language agnostic, and you don't have to worry about putting it in your code.
Exactly. Yep. Queuing is a big one because I say that because it's pretty straightforward. What people know, you drop a message on a queue, you pull a message off. From a migration pattern perspective, that's a pretty easy win. So you've got new functionality, something that's going on, new feature that's running. It's greenfield, it's running in AWS, but it still needs to communicate to applications running on-prem. So you can have an asynchronous communication where you take in the new request, drop the message on the queue, you have a queue processor on-prem, pick up the message, and it does something, drops data, and kicks off the back-end process that's running on-prem. So you can have one of those patterns where it's rather helpful, especially with applications that you can't move to the cloud. I see you're thinking. Yeah. Oh, you just look like you were just like, yeah. No, okay. What'd you say?
Nothing.
Huh?
Do continue.
Do continue. I'm watching you. Okay. And then network connectivity. One of the things that when we're moving applications and we're moving companies to the cloud, network connectivity is a big thing because they have to talk on-prem to a lot of the applications that are still running. So those greenfield apps will still have to do that. One of the things that an easy, quick way to set this up is a VPN. You just set up a VPN between your on-premise network and the cloud. Now, there's as you scale up, you don't want to use a VPN because it's inherently latent and it has other issues with it. You can add, in an AWS context, you can add direct connect. I forget what Azure and GCP call them, but those are direct physical connections into your network. You work with network providers, they set those up for you. And then, of course, there's replication. So if you want to move your development environments into AWS just for, to free up capacity or just, to do anything your devs want to work through, you still need data. So you have to replicate data out into AWS. They have services in there. If we're talking about petabytes, you can use Snowball. If we're talking about exabytes, they have, I don't know if you guys seen the snowmobile. It's a giant semi. They'll wheel a semi in and hook up to your data center, transfer all of the data, and then transfer it to AWS. It's ridiculous. I mean, you can with CMS you can provide your own encryption. You can provide your own data encryption, but yeah.
The snowmobile is carrying around an Apache Data Systems Terra server, and everything is encrypted for us.
Yeah. So there is that.
It doesn't become a giant.
Nice reference. Anybody? Johnny Mnemonic?
Yeah.
Yeah. Okay.
Keanu Reeves.
Got 2 gigs? I think he had 2 gigs in his head.
William Gibson.
Yeah.
I mean, Keanu Reeves is cool, but William Gibson is super
right?
cool.
The guy with the laser garrote,
Yeah.
that guy was awesome.
That movie had Ice-T in it.
Did
Oh,
it? Yeah,
and-
it did.
And it had Hank Rollins.
It was a good one.
That's right.
So we're gonna start talking. This is what we'll get into the serverless bit. Let's see how we're doing on time. 7:33. Okay, yeah, doing all right. So what is serverless? Again, we talked about, there are still servers involved. You just don't manage them. So again, it abstracts all of those layers away from you from a system administrator's point of view. You don't have to worry about patching. You don't have to worry about other than that. Anything like that. Words. It's event driven. So you've got your code sitting there waiting. You've got a nice little URL. Somebody hits it and it just executes what you need. And that's all it does. You're not paying for an idle server. You're not paying for anything. So you're paying for the execution time and any resource they're using. So from a pure cloud perspective, you really are only paying for what you use. And then again, there you go. I talk ahead in my PowerPoints because it's all in my head or my bullet points. So watch. I'll probably.
On the cost thing, is there an inflection point? Like if it's a limit to use that, then it's fantastic.
Yeah, because I think it's like under 1 million. Even on the free tier, it's still free. 1 million
Once you get that
executions.
inflection point, it becomes cost prohibitive at some point. I mean,
I don't know what the scale is. That's actually a very good question, and I'm writing that down in my head. But
You need a
They-
set of Post-its.
yeah, they. I was just gonna put it on my simple note. But Devin has been doing this a lot longer than I have, so he's very good at this.
3M loves Red Hat. You go through Post-it notes like they're doing on style.
Even still, though, the idea is that I think when we get to it, I think the idea is that you're not paying for the server time at this point. Again, it's that fraction of a millisecond of execution time versus having a server sitting there idle. Even if you are doing auto scaling, you've got it properly tuned to, at 5 o'clock on a Friday, you've got to scale things up because something's happening. So even if you are finely tuned from that perspective, there's still even more cost savings to just having that application running in a Lambda function and executing at that time. But I think that inflection point, that's a very good question, and I definitely will take it down.
Instagram or something. It's just it's crappy.
Well, even still, yeah.
Where's the ball? Where does that cost?
It varies a lot depending on the company. But we also massively dependent. But let's take, for example, a particular company and the cost of their messaging. And the cost of their messaging provider is outrageous. And imagine when you do a so that kind of application, even if it is higher load, you probably get a quicker injection point than any other. I'm going to enjoy it. Well, most industries,
So there you go. It's 2 cents per million requests.
yeah, so most industries, they have to spend,
Yeah.
and so they have to buy new hardware.
Yeah.
And so if you're looking at cloud, you have the hardware.
So yeah, exactly. I mean, I remember doing this at GE Appliances. I ran through one Black Friday scenario, and we would do, I think it was 3.5 times load on our servers, and I was writing microservice APIs on the front end in AWS, and I had no issues. It was the on-prem stuff that we needed to make sure that was ready to take that traffic. So in the cloud, you alleviate yourself from that concern. I think that's one of the biggest drivers when I say non-financials. Yeah, exactly. That's the whole idea.
Even those who there's a couple of different government agencies in the last couple of months. So the IRS has massive computer infrastructure that handles it completely. Right? The rest of the year, like 90% of it, they actually hire that. But they have to have it sitting there. So now what they're doing is they're reselling that extra capacity to other government agencies. And bringing up large sums of their IT. It's just redistributing the money in a better way.
Yeah, robbing Peter to pay Paul.
You're not robbing Peter. You're just letting that money go block.
I found this while I was, I forget what, somebody was presenting serverless, and I saw this, and I thought it needed to be added. Someone was trying to understand, I think they were making a jab or a quib at AWS, and then Adrian Krakow came back and said, if you can do that, then you can consider yourself serverless. So, I mean, because you've got to remember, Lambda at this point only has a 5-minute execution time, so that's the idea when you start talking about the architecture of your apps. It's, we're talking about functions inside of your service or an HTTP request that is a Lambda function. And that will become more apparent too once we actually start talking about the services. So I just thought this one was fun. It's always interesting when you see people try and take jabs on Twitter. Or from Twitter, exactly.
So, a question about serverless is the idea is a theory in practice. So people take monolithic applications and skip off little pieces to take these serverless things, or that they'll be from scratch, greenfield functionality.
I've got
tends to be more towards greenfield than brownfield. That said, there are people that can skip off pieces from the but, like I said, if you start taking a massive PLC system, strangling that monolith down into serverless functions, you're going to end up with 500,000 lambda. How do you cognitively understand how all those pieces fit? Maybe that was the wrong pattern of truth. Well, you wouldn't do it. You would go through different modernization. You take your monolith and you modularize it. Then you proceed toward like a majestic monolith, and then you find the hot load sites within that ERP, and you would strangle off that little. Yeah. And then you would find the next bottleneck, and if you still can't scale, you would strangle off that little. But for the most part, you want to keep your monoliths full because they operate much easier. They're easier to develop for. They're easier to improve features for. Only go to microservices and their function as a service when you absolutely have to reach a certain point. What's the fastest response time?
Depends on the runtime, and there's all the runtimes for them.
Do they have a runtime for Braille yet?
No, I think it was just Java. No, this I think these were from 2018. So one of our, I think we call him the VP of serverless because that's what all he talks about. But he's one of our VPs of engineering. He's an AWS ambassador, and he's ran this simulation. So this gives us kind of like the execution time and how long it takes to execute the same function in different languages. He's got a blog post out there too if you want to read it. These slides will be out there after I do the AWS modernization talk. So these will be available in about 2 weeks.
So if you go to Quarkus.io, you have similar numbers for GraalVM and GraalVS. And the GraalVM and GraalVS are orders of magnitude faster than.
Nice.
So if you want Java serverless, you might be looking at or JavaScript serverless.
I saw this from one of the reInvent talks last year, and the idea I like that this shows is the the arch of the changes of what you're shifting to. So a big thing is it says operational construct, but again, like I say, you're on-prem, you've got to manage everything. Everything is within your control. Everything's in your hands. Um, as you shift more towards serverless, you've got less operations. You're more worried about business logic, scaling. What is the core business value that you're giving to customers? It's not, setting up servers and running your applications. It's the applications and what you're providing to them. So that's what the idea here is, I think, in this arch. So at the far right, you see you've got Lambda and DynamoDB and S3. These are some of the services that we're going to talk about. Fargate. I don't think we'll get to cover Athena, but just being able to execute and run your applications and then scale those infinitely in quotes, or the size of your credit card. It's a different shift in thinking, and it frees up a lot of room for innovation. We've already discussed this with the runtimes. These are actually out there. I can post the link to this and a couple of the other things that I pulled some of this data from, just to give you guys an idea. When we talk about serverless and we talk about the shift away from operations, the term no-ops comes up, but as we'll discuss later, a fully serverless solution requires zero system administration, because we've already talked about it. It's a shift to tuning and re-architecting and making sure everything is running to scale. But if there's no ops, what is DevOps in a serverless world? Hate to burst everyone's bubble, as you kind of imagine, and as Devin's alluded to a couple times already, managing your Lambda functions and how you've architected your applications and set up your business teams, your development teams. Though that's where you're shifting the idea. So now, instead of an operations from a system administrator's perspective, managing servers, installing servers, all of these things, you're shifting things more towards the left, to the developers, to the architects, SREs, all of those guys who are in that realm. The big thing I think here that I want to talk about is that there's no OS tuning. So again, like we said, no kernel params, no things like that. You're tuning your services. Is it running at the optimal? Is it 18 milliseconds? Am I getting the latency that I want? If I'm not, what do I need to do to tune that? Is it an application-specific issue? Is it the runtime? Is it how I have it set up? Do I need to break it up further? Things like that. And then, of course, because these things are in an AWS or a cloud environment, monitoring, logging, and other ops, traditional ops tasks are built into the services. Now we get into doing some of the demos. I like this quib. I try to be funny. I like to think that I am. But yeah, I know I'm not. Yeah, that was funny, right?
You are.
Right?
You are.
Yeah, see, that was good. That was meta. Anyway, so when we're talking about serverless, the nice thing is that there is the free tier from an AWS perspective, but you can do almost all of your development and not cost anything from an AWS cloud perspective. And that's what I'm going to talk about here. So it's developing serverless development locally.
Is that even the case with like Kubernetes?
I don't think they have an EKS where you can do things locally and test it. You'd have to do something like Minikube, but not with integrations like what I'm getting ready to show you. I wouldn't think.
So, you think you need to prove something?
Yeah, they give it to you for free at the first go. Oh yeah, no, they do. So the nice thing, and I've taken a few hits. It's okay. So we talk about serverless application model. The serverless application model is their AWS's framework for developing serverless applications locally. You can, in a few lines of YAML, define what your API or what your service looks like, and then it will compile this all locally for you, run it inside of a Lambda, an API gateway container, and you can execute it natively like it would in AWS. I'll have it debug turned on so you can see everything that it's doing. You'll see that it generates the AWS requests between API Gateway and Lambda. You can see the signing. So it's very interesting from that perspective. And you can also deploy it to AWS with SAM. So it's CloudFormation on the back end, but it gives you, from a developer's perspective, I can drop my Python code or my X framework code into this framework, and it just deploys it for me and takes care of everything. So this is using Visual Studio Code. This is a nice little GIF. Comment.
So maybe after you deploy the code to be able to run serverless, right? So when you deploy the code,
On S3. Yeah, Lambda's code is sitting on S3. So you'll zip it up and send it. So when you do a SAM deploy, it will deploy it out to S3 for you. But starting here, again, it's doing the Lambda function. This is what's happening on the back end. You see how it's executing. The nice thing too is it even tells you, so right there, click away, how long you're going to get billed for 100 milliseconds. So here's the API function that you're setting up. There's the, it might just be easier just to do this locally. So setting up a Node.js app. There's the Lambda in we were talking about. There's the API, doesn't invoking the handlers, that's the Lambda function. And it's just going to set up something else. So it's adding another endpoint to it. So I'll go ahead and run through the demo exercise. Oh, that's right. I talked about ngrok. I'm going to go ahead and skip ngrok for now and just run through the demo and show you real quick how easy it is. And this is the part where I probably didn't create the demo guides because I have to sign into my AWS account. I got a lot of things I need to update. That is the first time that has ever happened, so it is a 2015. Pox in the house. Yeah, it's been running pretty slow since on Mojave? Wow. Well, I've got a lot of crap running in the background. Calm down. All right. AWS S3 LS. Let's see if I'm authenticated. Not good. Oh. I love it. I love it. All right. I'm using the right profile now. AWS S3. There we go. I've got some S3 buckets. Can you see it in the back there? Maybe now. Is that better? Good. All right. You can say something. This is it. All right. So the nice thing is you'll notice, ignore the fact that I stole these GIFs from there. I did. Oh, yeah, it's an AWS presentation. I'm working with AWS. Where's it at? Second layers. Step 2. I had, let's just go into the documents, code. So I've got SAM locally running. So I can do a SAM init, and I forget, you got to tell it the runtime. What do you guys want? You want a .NET? Yeah, .NET Core 1. Let's just go with the Python. The nice thing is that it generates all of this for you. So you go into the SAM app, generate all the stuff that we were just talking about. locally. And then I can do local API. Now I have these all in a make file. So let's go ahead and go to that make file. What? Can't. Yeah, I was gonna say I can't remember all this. You're welcome. You're welcome. So, like any other good sysadmin, I've got everything in make files. So let's start the API locally. So this is, like we were talking about, this is the hello world function that's running on port 3000. Again, I've not written anything. I'm missing an auth token from somewhere. It does, oh, that's why I have the -f profile here. It is executing, it's generating the AWS signatures for the communication between Lambda and everything. I don't know how familiar you guys are, but everything gets signed with AWS v4 signature, takes the credentials, generates a secret, encrypts everything. You'll see once I actually run it properly what I'm talking about. This is all the stuff that happens on the back end on AWS that you don't normally see. They don't have any environment variables. Start it back up, it's running. This is the fun part about live demos, right? Let's go to the /hello because I don't think it has anything defined at /. So since I'm not running the Python container, it's gonna go out, grab it, did the /hello, it's gonna go generate the credentials, it's pulling down the Docker image for running Python Lambda locally, but we can pull up.
But it only has to do that.
It only has to do that the first time, absolutely. So if I run that again, it should be a little bit faster, minus my laptop. So you see it did the hello world. There it all is. So that's SAM. So I did a SAM init, generated the Python for me. So does all of the Python application. You can drop your own in. You can do what you need to. Let's look at the template. So again, if any of you guys are familiar with AWS, you can, this is starting to look a little familiar because this is just CloudFormation. It sets up a function, there's a serverless function, as your Lambda handler, that's where everything's at. It's only got the one event. So when it sets up the event, so there's the function and the API gateway as the properties. And then here's the API gateway telling you all of the execution. So if I wanted to now, I can do a SAM deploy and got to give it a template file, like I said. Where's it at? Template.aml, and I've got an S3 bucket, so let's just go ahead and deploy it to one of the ones I already have. So I don't have to create another one. AWS 3ls. Oh, look at that, I've got one. Gonna yell at me stack name because this is gonna be the CloudFormation stack name. And then I think I need one more, which is the S3 bucket to upload the code. Or not. So right now it's going up to AWS, creating the, it was going to create the CloudFormation. So the users don't have to worry about all of that. Let's see. So the fun bit of all of this is that It's all part of the AWS CLI. Profile, debug, stack name. Not looking like it wants to do that. Number of errors, required source ID hold is invalid, code UI is not valid on the S3. Oh, where it expects the S3 code to be. Let's go ahead and when was it? Them on the fly, right? If that works now. So the idea here is that I do the deploy, it zips up the code, uploads it to S3, and then changes the version in the API gateway, and that's all really you have to do. And yeah, the capabilities. I like how it doesn't tell you that here. I'm missing a parameter. Note to self, script the demo. All right, so that was the development locally for that. I'm gonna skip the ngrok. That was this piece that we were talking about. Oh, you know what? That should be the actual thing that I was gonna run. Create the bucket name, do the init, create it, package it up. There's the step that I missed. You have to package it up, and then there's the capabilities. Because you're using CloudFormation, I don't know if any of you guys are familiar with CloudFormation, is that when you're creating IAM roles, you have to tell CloudFormation specifically, yes, I know I'm creating IAM roles. I know what I'm doing. Yes, this is okay. So it's like a double check when you go to do a delete. It's like, are you sure you want to delete? Yeah, I am. So that's what this one is here. So you create the S3 bucket to host your code, do the init. You can do a build, and then you package it up. That's doing the zipping up the code and packaging it and setting it up in the S3. And then doing the deploy is where it deploys the API gateway and the Lambda function for you both. So since we've already had pretty bad with the demo, I'm going to go ahead and skip that. I think I'll just cover this one last piece, and then I can let you guys go unless you guys want me to keep talking, because I can, or you can, but I'm going to go ahead. These are the labs. I will post these. So these build on top of each other. So you'll deploy a DynamoDB table in this lab. You'll populate it with some data. And then in the next lab, you'll create a Lambda function that's going to consume that data. And then at the last one, you'll create an API gateway where you can hit, and it will run through and do all of this for it. And then the last one is using deploying an application on Fargate, which is AWS's serverless. And then just the last bit before we go, I just wanted to walk through this one, just to give you an idea about that modernization effort of what it would take. So this is a pretty standard, 3-tier web application with an authentication piece and a load balancer of what people would be running. And then just slowly walk through what it would look like when you convert it to a cloud native or a serverless. You can I don't know if a lot of you know, but you can host websites on S3. They actually have specific features and functionality for that. So if you hosted a JavaScript or Node.js application that can interact with backends, so you can have a fully functioning website running off of S3. And again, you just pay for the storage and the data transfers. So that's the piece of that. So you're converting your web server and your static code, your static assets, all of those things onto S3. Moving your application logic into Lambda. Again, serverless, you just worry about your code and you just scale it as needed, or it scales as needed without you having to do anything. There's a serverless application called Cognito, where it can, the best way that I describe it is it's OAuth as a service. So you can set up user login pools and you can have your applications reference those. So instead of having to set up your own OAuth service, you can use the Cognito service. We talk about moving away from and being able to scale those services and being able to monitor, throttle, and do all of the things that you would expect to be able to do from a load balancer's perspective. You can navigate that and do it with API Gateway. And then last of all, the big kahuna that we talk about is the database. So managing your databases from a serverless perspective. If you're not using Aurora for a SQL compliant database, you can use DynamoDB for NoSQL. And again, you have the serverless functionality there. You just tell it how much capacity you want and how much you need, and then you just go. So that's a part of being able to take an on-prem 3-tier web application and running it solely and incrementally onto AWS. Questions on that one? I see you smirking back there.
There are always.
Oh yeah, no, this,
and
yeah.
not enough time, but here's the thing.
It's not as easy as I just,
It's
not as easy as the picture that I just painted, but the idea is that you can, some of these things you can incrementally do. Some of them have to be done all at once. And again, that's all part of the discussion when you look at your application portfolio and what do you want to do? What are some quick, easy wins? And what will take a little bit longer time. And again, looking at those 6 R's, are they worth the effort? Because again, all of this does take, you've got to upskill your people. They've got to understand. You've got to put structure around with your AWS accounts, any of your cloud accounts. So there's lots of other diligence, and that's all part of the cloud adoption framework. They even go into talking about business roles and how this changes people's changes those roles and responsibilities, and setting up cloud centers of excellences, and setting up your initial accounts and how to structure all of this. So this is very much simplified for the demonstration and presentation purposes, but it is doable.
Oh yeah, I'm just looking at getting this far.
Well, everything that we just did 1, 4, and 3 with 4 lines of code, and I didn't write any code. It was all done on the back end for me. The only thing we didn't do was integrate it with a Cognito pool. And I've also got some other labs. Where I stole this was an AWS lab, and I've got that, and I can post it to the meetup that you guys can run through. The only thing about this one, though, is that it's not part of the other ones that are later, that are in Quick Labs. You'd have to have your own AWS account. But again, most of this stuff can be done within the free tier. So I've got more content. I got a lot more content because this is a 7-hour workshop that I'll be working through, and I've sped through a lot of this. The labs themselves, there's 4 of them, and they're about an hour a piece, and they're a credit on Quick Labs. So if you want to run through them, you're more than welcome to. But for now, I'm kind of done because we're kind of at time. I've been speaking for about an hour now. You guys have any questions, comments, thoughts?
Can you share your dot file that you're using in that terminal? What terminal is that?
It's iTerm 2, but it's just Solar. It's a Solar theme for iTerm 2.
Okay, so that's